In this video, we're going to continue our discussion on piecewise functions. In the previous video, we looked at an example of a scenario where a piecewise function might be useful. So we had a different rate per gallon of water based on how much water had been used. And so when we graphed this scenario, we had two different pieces, and these are just each of these is part of a line, but they're part of two different lines. The red one has a higher slope, and therefore it's a more steep line. So that's going to be the case with piecewise functions. Each piece is going to be described by a different equation, essentially. We're going to stick with ones that are only linear pieces, but you can have piecewise functions where one of the pieces is defined by a curve as well. We ended with evaluating our function. So we had written the function, we had the criteria for which x values each piece was valid for. So the first piece was for anything up through 5,000 gallons, and then the second piece was only valid if we were using more than 5,000 gallons. And so when we evaluate a function, we're substituting the number in parentheses for x, and we should only get one result. So we're not substituting at both places here because each input for a function can only give one output. Otherwise it wouldn't be a function. Notice how on our graph, right, for an x value of 1,000, we only had 1 point. We didn't have another point somewhere up here. That's because there's only one cost for 1,000 gallons. If you ask how much am I going to get charged for 1,000 gallons, it wouldn't make sense for them to give you two different answers, right? So we're going to keep that in mind as we move forward into some more examples here. So here we have a piecewise function, and it's defined by x for x less than or equal to 1, and it's defined by negative x plus 3 for x values greater than 1. So the first thing we're asked to evaluate is f of 0. And so that means we're going to substitute 0 for x and find the function value. But where should we substitute 0 for x? Should we do it here or should we put it here? And that's where we need to check which criteria this fits. So is 0 less than or equal to 1? Yes. Is 0 greater than 1? No. So we're not using the second piece, we're using the first piece. And if we substitute 0 for x there, we just get 0. Now we have an x value of 1, so again we need to decide which criteria does that satisfy. Is 1 less than or equal to 1? Yes, because we have that equality being included there. 1 is not greater than 1, so since that's a strict inequality, putting 1 in for x there would result in a false statement. So we're not using the second piece, we're using the first piece again, and so we're substituting 1 for x there. Now if we look at the x value of 2, if we put 2 in for x here, we get a false statement, right? 2 is not less than or equal to 1. However, 2 is greater than 1. So for this one, we're going to substitute 2 for x in the second expression. So just keep in mind when asked to evaluate a function for one x value, you should only get one output, one y value. Now let's graph this. I think it makes sense to start with one piece at a time here. And so for the piece where x is less than or equal to 1, what I like to do is I like to picture a number line. And I think about what would happen if I was graphing this inequality on a number line. So I'm graphing x is less than or equal to 1 on a number line. I'm going to have a filled in circle or a bracket if you're doing it that way, depending on what notation your book uses. And then we're graphing everything to the left, right? Numbers like 0 and -1 would satisfy this, but 2 would not, right? So we're graphing everything to the left, and it's just going to keep going with an arrow. That's helpful because when we go to graph this, that's essentially what this piece of the graph should look like. It should look like a filled in circle at an x value of 1, and then it's going to go forever to the left with an arrow. Now it's not going to be a horizontal line necessarily. We have to look at what line is being given in the equation. And so what we're going to do is we're going to plot some points so that we can draw this piece accurately. But the general gist is it's going to have a filled in circle somewhere where x is 1, and then it's going to go to the left. So we definitely want to know where to put that circle, right, where this piece is starting. So substituting 1 for x is a good idea, and we actually just did that on the previous slide. When we were asked to find f of 1, we substituted 1 for x in the first piece because that's where it was allowed. And then you only need 2 points to graph a line, so just pick any other x value that's less than 1. We already looked at 0 on the last page. We plugged in 0 and got 0. So then we can plot these 2 points. And then I think the thing that trips some people up is, how do I draw this now? I'm not drawing the entire line. Remember, I'm only drawing part of the line. And that's where this number line comes in handy. We're only graphing this piece for x less than or equal to 1, which means start at 1. So start at this point here that we plotted, which has an x value of 1. And then we're going to the left because we're looking at x values that are less than that. But we're not going horizontally. We're going to go through that second point that we plotted to make sure that we're drawing the correct line. So essentially what we've done is we've graphed part of the line y equals x, because that expression, that first expression, was x. So we graphed part of the line y equals x there. But we only graphed it for x values that were 1 or less. Alright, now the second piece is for x values that are greater than 1. So if you think about how you would graph that inequality on a number line, now we're ignoring everything over to the left. We're going to be graphing numbers like 2 and 3 and so on. But we want to get as close to 1 as possible. And so some books will use parentheses, some books will use an open circle at 1, and then graph everything to the right of that. That just shows we're going right up until 1, but we're not including it. So for the second piece, we're graphing part of the line y equals negative x plus 3, because that's the expression that's given there. And this piece is going to look similar to what we just graphed on the number line here. We're going to have an open circle at an x value of 1, and then we're going to graph this line just going to the right of there. So even though x is not allowed to be equal to 1 for this piece, we need to know where to put the open circle. We know it has an x value of 1, but what should the y value be? That's going to come from knowing if we were graphing the entire line, y equals negative x plus 3, what would be the point with an x value of 1? What point would it pass through? So I like to put this in parentheses to remind myself it's an open circle. But if we substitute 1 for x here, we get negative 1 plus 3, which is 2. So this line would have a point at 1, 2 if we were graphing the whole thing. And so that's where our open circle is going to go. And then from that open circle, it's going to go to the right, like our number line does here. And so we can pick any number greater than 1 to get our second point. I'm going to use 2. So if we substitute 2 for x, we've got negative 2 plus 3, which is 1. So there's going to be a point at 2, 1. And then we're just going to start at the open circle and go to the right and make sure we pass through that second point that we just plotted. Then we were asked here to use this graph to identify the range of the function. The range is the set of y values that appear on the graph of the function. So both of these pieces have arrows pointing down, which means as we head toward negative infinity on our y-axis, we're just going to keep going and hit every single y value as we go down. So the range has no lowest value. There's no lowest y value on the graph. It's just going down toward negative infinity. And then as we follow each piece up, this one stops at 1, but this one keeps going. So we have y values, right, of 0, a half, 1, 1.25, right? It just keeps going up until 2. We don't have any points on this graph with a y value of 2 because there's an open circle there. There's no points anywhere else. So every y value on our y-axis shows up as a point on this graph until we get to 2. And so we'll use parentheses there to show that. I wanted to show one more example here because this one's a little bit different. So we've got two pieces again. And our first piece is for x values that are less than or equal to 2. And so if we graph that on a number line, we would have a closed circle at 2, and we'd be shading to the left because that's where numbers are less than 2. So we're definitely going to want to substitute 2 for x to see where that point goes, and then we can pick any number less than x. I'm going to pick 0 just because it's easy. And we're graphing the line y equals x plus 1. We're graphing part of the line. So if we plug 2 in for x, we get 3. If we plug 0 in for x, we get 1. So once you've plotted your points, then just think carefully about how to draw this. We're starting at the point with an x value of 2, so we're starting at this point here, and we're going to go to the left, making sure to pass through the other point that we plotted. So that's the first piece. Now the second piece is for x values that are greater than 2. So open circle at 2 and shade to the right is what that would look like on a number line. So again, we want to know where should that open circle go. We know it has an x value of 2, but what's the y value? And then we need to pick another x value, something greater than 2, and substitute it in. Now, we actually don't have a place to substitute it in here. It just says 3 for that second piece. So this is just the line y equals 3 that we're graphing, which is a horizontal line. All the y values are 3. So we'd have points like 2, 3, 3, 3, 4, 3, 5, 3. Now notice how this point where we're trying to put an open circle is actually the same as this point here. If the point already exists for the function, then there's no need to put an open circle. This should be a filled in point because for this function that we're graphing, when x is 2, y is 3. That's coming from the first piece, and so all we're doing with this now is just kind of extending from that point. So sometimes that happens where the two pieces will actually line up, like the end point of one is the exact point where the open circle would have been for the other one. And so that results in a filled in point because when x is 2, y is 3. So if we plot this other point here, 3, 3, then we're just starting at 2 and going to the right. This time it is a horizontal line. And so that's the second piece of the graph there. And then once again, we're asked to find the range. Just like the last one, the arrow pointing down indicates that we're coming from negative infinity, and then we hit every y value along the way until it stops at 3, and we do have a lot of points with a y value of 3. As long as we have at least one, that number 3 is part of our range. And we don't have any y values above 3 showing up on this graph. So that would be the range.